In the final step of the machine learning pipeline, we're going to finally train a Lasso regression and evaluate its performance utilizing only the selected features. And we selected these features in the previous notebook. So we're going to import joblib to save the trained algorithm. We're going to import Lasso, which is a regression model that we want to train. We're going to import the mean square error and the R-square score from scikit-learn to evaluate the model performance. We load the transformed datasets. We obtain these in the second notebook of this section. We load the transformed target. This is the log transformation of the original target. We also perform and save this transformation in the second notebook of this section. And now we read the selected list of features which we determined in the previous notebook. These are the predictive features. Now we reduce the size of the dataset to those features that we selected previously. And now we fit a Lasso regression with the same alpha that we used in the previous video and the same random state for reproducibility. We fit the Lasso to the train and the target. This procedure learns the coefficients that are going to be applied to each variable in order to obtain the sale price. And now we evaluate the model. We obtain the predictions for the train set with the model.predict. And now we print first the mean squared error utilizing the mean square error function from scikit-learn. And now we transform the original target, because originally this is the log transformation of the sale price. So we want to go back to the original sale price. And we also transform the prediction, because the prediction is also in the log scale, and we want the full price of the house. So we obtain the mean square error of these values. And then if we use the same function, and we put squared equals false, we can also obtain the root mean of the square error. And utilizing the R2 score, again passing the transformed original target and prediction, we can obtain the R score. And then we repeat the exercise on the predictions obtained in the test set. This bit of code is very similar. And we can see the accuracy of the model is fairly good. We have an R-square of 87 in the train set and 84 in the test set. If we then plot the predicted house price versus the true house price, we see that it follows a line that is quite accurate and the values tend to be quite representative. And now we can go ahead and explore the residuals, that is the difference between the original sale price and the predictions, and if they follow a Gaussian distribution like they do here, centered at 0, which means that our model did a pretty good job. We can go ahead and evaluate the importance of each feature. The importance is given for a Lasso by the absolute value of the coefficients, which we obtain like this, and then we can plot, and we can see that the ground living area of the house is perhaps the most important feature, followed by the overall quality, and then the subsequent features in order of importance. Now we're going to save the model for later use. And that is all for this video. If you want to know more about the steps of the machine learning pipeline, here I add a few resources.